So we will be starting chapter 5. And chapter 5 is about interest rates, which is one of the important variables that we have to use in order to do the time value exercises that we did in chapters 3 and 4. So how do we come up with that discount rate, and what are the implications of that? We will learn a little bit in this chapter. So interest rate, we often view interest rate as the price of using money. What does that mean? It means that interest rate is the rate at which I exchange today's consumption for tomorrow's consumption. For example, this is, let's say, I am representing my wealth today at time 0 on the x-axis, and my wealth at time 1, next period, let's say a year from now, on the y-axis. And let's assume that I start with an initial wealth of $100. If I consume all of that $100 today, then I would be left with nothing tomorrow. On the other hand, I can make a decision not to consume anything today, so consume 0 today. So the question would be, what would I receive? What would I be able to consume tomorrow, a year from now, if I do not consume anything today? And the answer will depend upon how much I will have tomorrow, will depend upon this price of money. What is the rate at which I am exchanging today's consumption for tomorrow's consumption? If that rate of exchange is, let's say, 10%, then this consumption tomorrow would be 110. How? We know this. So future value would be the present value of 100 times 1 plus 0.1. So that would be 110. 0.1. So this R is essentially expressing for me the rate at which I am giving up consumption today for tomorrow's consumption. If I consume $100 today, I will have nothing tomorrow. I will be here. If I do not consume anything today, I will have $110 tomorrow. And then something in between. Let's say I consume $50 today. Question is, how much will I have left over to consume tomorrow? I will not have 50 left over, but I will actually have 50 times 1.1, which would be $55 left over tomorrow. So it is this interest rate that is determining the rate at which I am exchanging today's consumption for tomorrow's consumption. So from this basic understanding, we look at effective annual rate, or also called the EAR, sometimes also called the annual percentage yield, as the interest rate that will be earned at the end of 1 year. Another way of looking at this would be, if my future value is 110 and my present value is 100, I have 1 period for my investment. What is my IY? My IY would come out to 10%. So that 10% is the interest rate that I am earning at the end of this 1 year process. Over this 1 year of investment of 100 today, 110 tomorrow, would imply that I have earned an interest rate of 10% over that period. And that's my effective annual rate, or EAR. So here is a quick example. So if an EAR for an investment is 5% and you invest $100, then this becomes your present value because you're investing that today. R is the interest rate, and your future value would be 105. So this $100 investment grows to a $100 investment at the end of 1 year grows to 105. What if I'm investing the same $100 over 2 years? So this $100 grows to 105 at the end of 1 year. Then I invest I reinvest all of that, the 5% interest plus the $100 of principal, and I grow my total investment to $110.25 at the end of 2 years. So what's another way I could have gotten from here to here? By taking the present value, multiplying that by the discount factor, which is 1 plus r to the power n. N in this case is 2. N is equal to 2 in this case. And I would have gotten here. Another way I could have gotten from 100 to 110.25 is to multiply 100 with this, 1.1025. Where do I get 1.1025? I get it by 1.05 square is 1.1025. So I could have gotten from here to there. So effectively, the interest rate over my 2 years is 10.25, which is based on an annual effective annual interest rate of 5%. So this way, through this understanding, we can adjust the discount rate, this interest rate of R, to account for the different time periods or the time horizons that I have for investing. And we do this by raising the interest rate factor, which is 1 plus R, to the appropriate power. So 1 plus R to the power n, we can calculate the equivalent interest rate for any n period, just like we did over here. Over the 2-year period, my equivalent interest rate is 10.25% over 2 years. But on an annual basis, it's 5%. So 5% annual over a 2-year period is equivalent to 10.25% interest. So over here, what would be, if I have effective a yearly rate of 5%, so my EAR is still 5%, what would the equivalent interest rate be over each half-year period? If I'm assuming instead of going from 1 to 2, I go from 1 to half. So now from year 0 to end of year 1, I know my future value is going to be 105. I know that because the effective annual rate is 5%. So 100 or 1 times 1 plus 0.05 is 105. But what would be the interest rate over the half-year periods over here? What will that be? It is not as simple as dividing the 5 by 2, because that would give me 2.5%. But that's not what we have here. Because if you multiply 1 with 1.025 and then multiply that by 1.025, you will end up with more than 1.05. So how do I calculate the half-yearly interest rate? I take 1 plus the effective annual rate and raise it to the proper n. In this case, n is 0.5. N is 0.5, and I get 1.027. That means my half-yearly interest rate is 2.47. So another way of saying it, a half-year interest rate, a 6-month interest rate of 2.47 is equivalent to an annual rate of 1.05. Okay. So the equivalent n period discount rate is then 1 plus r to the power n. We subtract 1 from it, where n can be any number. It could be half year if it is a half year period. It could be 2 if it's a 2-year period, and so on and so forth. Okay. So here is a quick example. Suppose your bank pays interest monthly. Okay, so not annually, but it tells you that the EAR, or the effective annual rate, is 6%. How much interest will you be earning each month? That's part one. And if you have no money in the bank today, how much will you need to save at the end of each month so that you can accumulate your investment to $100,000 in 10 years. That's the second part. So the first part, since you're going to be investing on a monthly basis, that's why you need to convert this EAR to an interest rate number that is monthly. And the way we convert that, so first step is to convert the EAR to a monthly rate. And then we will go to the next step. So to convert the EAR to the monthly rate, what do? I multiply 1 plus R to the power n minus 1. That's the general formula. R is effective annual rate is 6%. N is going to be the period over which I'm compounding my interest rate. And in this case, I'm doing this thing monthly. So this period is going to be 1 over 12. And then I'm going to subtract 1 from it. So the way you can do this on the financial calculator, I'm going to show it to you very quickly over here. So the way you can do this, it'll be 1.06 raised to the power 1 over 12. So it'll be 1.06 y to the power x 1 divided by, you have to first calculate 1 over 12 separately. So 1 divided by 12 is 0.0833, and then you get 1.06 y to the power x 0.0833, and that would be 1.0049, and then you will subtract 1 from it. So that would give you 1.0049 minus 1. So that will give you so it'll be the answer was 1.0049, which is 0.49%. So I'll subtract 1 from this. Approximately will be 0.49%. So okay, now that I know this to be 0.49%, then the question is, what will be my annual payments? Now I have series of monthly payments. The interest rate over that period is going to be 0.49%, and this will be from month 1 to month 120, so 12 months, 10 years. So my future value I already know is 100,000. I know the periodic interest rate is 0.49. I know the number of periods to be 120. What am I left to solve? My unknown is what's going to be my annuity payment. That's the unknown that I have to solve. So what is going to be the C amount of monthly payment that will get me to 100,000? So the best way to do this is we go to our financial calculator. Okay, so we go to our financial calculator over here, and we do a second clear TVM, clear everything. And what are the input variables? 120 is N. IY is going to be 0.4868 or 0.49 IY. We don't need to input any present value. future value is going to be 100,000 future value, and I'm going to be computing payment, which is going to be 615.46. There's an error over here. This should be payment. 615.47 is going to be my monthly payment, which I'm saving at the annual rate of 6%. So the EAR is 6%, but since I'm depositing this money monthly, my monthly interest rate is 0.4868. My monthly interest rate is 0.4868. That gets me to 100,000 with a 615.47 deposit each month. That gets me to 100,000. There's no need for this negative sign here. Okay, so if we save 615.47 per month and we earn an effective annual rate of 6%, which is key part over here, it is equivalent to 0.4868% per month, then we will have $100,000 saved in 10 years. Okay. Similarly, you can solve for another problem like this. The effective annual rate is 5%. Future value is 150,000 in 20 years. How much will that accumulate to? So the first step, it would be we solve for the monthly interest rate, and then we use that monthly interest rate as an input over here. So n becomes 240. Again, this should be payment. So these are my input, n, iy, and future value, and I solve for payment over here, 369.64. Similar problem. So now we go from EAR to annual percentage rate. Annual percentage rate indicates the amount of interest earned in 1 year without the effect of compounding. The key part over here is without the effect of compounding. So simple interest is essentially like a simple interest that is earned without the effect of compounding. So how do we, in other words, if I take out the effect of compounding, what would be the annual percentage rate I'm earning over a given investment opportunity? So because the EAR does not reflect compounding, the APR does not reflect compounding, I cannot use APR. It cannot be used as a discount rate. Instead, the APR is simply a way of quoting the actual interest rate earned each compounding period. So interest rate earned per compounding period is essentially we take APR and divide that by the number of periods within the compounding period. And then once I have APR, I can convert that into an effective rate. Okay, and the way I do this, I take the APR, the annual rate without compounding, divide that by the number of compounding periods, add 1 to it, raise the whole thing to the power m, and that gives me 1 plus EAR. So EAR itself would be, then I would subtract 1 from it, and that would give me EAR. So that's the way to look at it. So over here, if the APR is 6% and I'm compounding once per year, then EAR, or effective rate, is also going to be 6% because the number of compounding period is annual. But once that number of compounding period is anything but annual, then EAR begins to change. The nominal APR is also the nominal rate. The nominal rate is 6%, but I'm compounding it twice a year. The effective rate will become 6.09. If I compound it monthly, the effective rate becomes 6.16, meaning effectively you are earning 6.16 over that period. The way to view this thing would be the following. Let's say I have $100. I invest this at 6%. I know my future value is going to be 106. But what if I compound it semi-annually? That means my APR is 6. I'm compounding it semi-annually. So this is interest rate per compounding period is 3%. So interest rate per compounding period is 3% and 3%. So now if I invest that $100 in 6 months, this becomes 103. What does 103 become 6 months later? It's 103 times 1.03. And that would be it'll be 106.09. Okay, we can try this out over here. So clear everything. Second, clear TVM. If I use 100 as my present value, 2 is my N, 3 is my IY, and I compute future value, it is 106.09. Okay. So effectively, what is the interest rate that I earned over that period? I can go back over here, again, second clear TVM. If I put 106.09 as my future value, 100 as my present value, N as my 1 year, then I'm computing IY. Oh, I forgot to change the sign. So 106.09 is my future value. 100, change sign, present value. N is equal to 1, compute IY. My effective interest rate is 6.09%. Another way in which I could have calculated that is to use this function in the financial calculator called iConvert. So I do second and the number 2 key. Second and the number 2 key. Then I do a second clear work to clear out whatever previous calculations I had. Now I'm going to enter my nominal value, which is my APR of 6%. Enter. Then I go down until I get to the display C/Y. It is asking me how many periods am I compounding per year. Since this is semi-annual compounding, so C/Y is 2. I enter that. Then I go up arrow back to the effective display, the display when it reads effective, and I do compute. I get 6.09%. So either I can use the formula or I can use the iConvert feature within the financial calculator. Either way, I get the same thing. Okay, so here is a problem. You can purchase a system for an upfront cost of $150,000, or you can lease the system at $4,000, paid at the end $4,000 per month on a 48-month lease. Your firm can borrow at an interest rate of 6% with monthly compounding. Should you purchase the system outright or do leasing? It's a very practical problem. Do you borrow to buy the system or do you lease? When to buy or when to lease? That's a pretty practical question. It happens in a personal situation. Do you want to buy a car? Do you want to lease a car? If those are the terms that has been available to you, then you can work out the problem in the following manner. It's a 48-month lease with $4,000 of payment. So that reflects my payment or my C, my cash flow each year. Payment or each month. Payment or C each month. So now from that payment, what's going to be my present value? So N is 45. Well, the key question is what's going to be IY? It is 6%. So APR is quoted at 6%. That's the nominal rate. But compounding is twice a year. So effective interest interest rate per period is going to be 6 over 2 or sorry, compounding period is 12, not 2. It's monthly compounding. So 6 over 12, which would be 0.5. And that's what we have over here, monthly compounding. So I have N, IY, and my payment of 4,000. I don't need to enter that as negative, just 4,000. And I compute present value. So I can do this over here, clear everything, clear second TVM, clear work. So 48 is my N, 0.5 is my IY, 4,000 is my payment, and I compute present value, 170,321. So what's going to be my evaluation? Should I buy or should I lease? Paying $4,000 per month over 48 months is equivalent to paying 170,321 today. And this is higher than what was the outright purchase price of 150,000. So it is better to pay 150,000 for the system rather than lease it. Okay. Another very similar problem, you can work this out on your own, practice this on your own. Several other examples, very similar. Now we want to look at something different. How do we apply discount rates to loans? Consider a timeline for a $30,000 car loan with an APR of 6.75 on a 60-month term. What would be the monthly payment? If you go to a car dealership, that's what you should be looking for. You will ask for the price of the car, which is how much you would have to take out in loan. You will ask for the APR or the interest rate, and you will ask for the loan terms, the monthly term, the time limit of the loan, and then you will be able to say, you will have to figure out whether you can afford the monthly payment. So in this case, N is going to be 60. The key input over here is this one. Why is it 0.5625? It is 6.75 is my 6.75 is my APR over 12 or monthly compounding will give me 0.5625. And that's the 0.5625 that I'm entering over here. Present value is going to be 30,000. You have to put this as a negative, and payment would then you're computing payment, which then calculates out to be $590. So a quick exercise over here on the same problem. We clear second TVM. 60 is our N, 0.5625 is our IY, right? And 30,000 negative is my present value. I compute payment, which is 590.50. If you don't like that payment, then the best way for you to reduce the payment would be to shop for the interest rate. You look at different other banks or credit unions to find out if somebody is offering you a lower interest rate. Let's say interest rate, so you find a place with an interest rate of 5%. So it'll be 5 divided by 12. So all you have to do is to redo the monthly payment. Is come over here, and it is 5 divided by 12, which is 0.416, and enter that as IY and compute your payment again. Your payment goes down to $566. So it pays to comparison shop. When we look at a loan, when we start with the loan, initially, so based on this payment that we have 590, the question is, as I pay down my loan every month, what portion of that payment is going towards interest and what portion is going towards my principal? In the initial months, most of it is going towards interest, and some of it is going towards principal. As you proceed through time, the interest payments begin to fall, and what you are paying off is mostly the principal. So the principal outstanding declines as you proceed through the loan term. So again, the same problem, 3 years now, 30,000 car loan, 6.75 APR. So the question now is, you are 3 years into this car loan that you had just taken, okay, on that $30,000 loan. So initially it was a 60-month loan, but now you are 3 years into it. So it was a 5-year loan, 1 through 5, 1, 2, 3, 4, but you are now 3 years into the loan. So all this time period is passed. You are standing over here, 2 more years left for the loan to end. If you want to pay off the remaining balance, how much do you still owe to pay off the remaining balance? And how do we find that out? So the monthly payment we had calculated was $590.50. So you have 2 years left, or 24 months left. One way to find out the remaining balance is to use the $590 as your payment, $590.50 as your payment. Again, 0.5625 is IY. The key part is now there is 24 months left in the loan. So what am I computing right now? I'm computing present value. This tells me how much I have left. Since I have 24 payments of $590.50, the present value of that 24 payments of $590.50 at an interest rate of 0.5625 per month, or 6.75 per year, is $13,222. So that's the way you would be able to calculate what percentage, what amount do you owe that is left over once you are made the payment. Alternatively, what you could have done, you could have taken the balance, 30,000, over those 3 years and calculated not the present value but the future value. That means you have, that's what you have. Those payments added up to 13,222 over that 3-year period. But I suggest this is the more intuitive way of asking the question, how much is left? Once you look at the payments, the time that is left, use the IY that is effective for this problem, and then compute the present value. Okay. So very similar problems. You can review them on your own. So I'm going to stop over here for this part and then continue on this chapter in the second part.